Good afternoon and welcome to our final presentation of our research project that we conducted this semester. Our paper is entitled A Study of How Standards-Based Reform, such as Common Core and Revised TEKS, has impacted mathematics instruction for elementary students. My name is Gustavo Perez, and I will be joined later in the presentation by Timothy Larramore, Andrew DeBaca, and Marcus Bones. So at the very beginning of this process, we decided to come together and form the Burkett Research Group. We have worked on a couple of other projects in the past, and so for this one, we decided to come together and work on this project. So what's interesting about our group is that we have two of us are more reading social studies minded, and the other two are mathematical science minded. So we bring a balance, we're sort of balance it out from a team perspective. So at the beginning of the project, there was a number of topics that we were interested in, some of which being COVID crisis that we're living through and how pandemics or things like that in the past, how they have influenced or changed education throughout our times. Another is distance learning. We wanted to know about how now that most districts are more than likely going to remote learning and how that can impact education as well. And then there was a number of other issues in education that we looked at. But as we were doing the research, we came across a lot of literature over how gaps in education begin early in elementaries. So we decided to stick to mathematics, and for the problem statements, we came down to 5 different problems that we're noticing in education. The first being that mathematical gaps, like I mentioned earlier, for students begin in early childhood education, as early as kindergarten, K2. And so what ends up happening is these gaps continue to increase as students continue their education towards middle and then high school. Another issue that we ran across in a number of the research that we conducted was that traditional instructional methods impede student achievement. Some examples include rote memorization. In a math class, we read about a lot of how teachers are using rote memorization as a skill and practice. It's a good skill, but students are only learning how to do their timetables or their math facts instead of taking in the learning and using it in other ways. Another example of this would be numerical values. In a simple math addition or subtraction problem, teachers are simply teaching the strategy on how to solve the problem, and not necessarily, the student is not necessarily understanding the numerical values of the 10 digits. So, and then the last example would be teacher-centered instruction, and how we're trying to move away from that and make it more of a student-centered instruction, where students take ownership of their work and are able to use thinking strategies to better their learning. Furthermore, we talked about and we also read about how there are some teacher evaluation tools, and here in Dallas ISD we use the TEI system, and how these systems seem to have a negative effect on student learning. Teachers from 3rd grade on, since this type of system pays teachers for performance, we notice from our experience and from the literature that teachers are mostly just teaching for the test, for students can pass the test and make more money. So it's impeding the learning instead of better. The fourth problem is that we came across a lot was how standards developed pre-Common Core and pre-revised TEKS are being used. Educators are using them for more of test prep rather than using it how they're intended to enhance the student experience. So when we put all of this together, we came up with this problem statement. how beginning mathematical instruction leads to gaps in secondary math knowledge, which then continues into college as well. So thank you for taking time out. I am now going to pass it on to Timothy, where Timothy will introduce and go a little bit more in depth on the research question. Thank you.
Thank you, Gustavo, for going over the problem for our group. The next section is our research question. So after discussing with our group several different topics, we talked about the COVID crisis, distance learning, and several other things, we decided to go in the direction of mathematics. So our research question became, how has standards-based reforms such as Common Core and the revised TEKS impacted mathematics instruction for elementary students? Because we wanted to address the problems that our students are having once they get to middle school and high school. So as we really got into our research question, we were looking at the intended purpose of the standards-based reform, which was to increase rigor and deepen mathematical comprehension for students. Instead of just being able to solve math problems, we really want our students to be able to understand mathematically what they're doing. We really wanted to do research and find out if the Common Core and new TEKS were actually accomplishing the goal, or was it were they not accomplishing the goal, which is why we're still seeing gaps in our students' learning. As we were developing our question, we had other questions that helped guide us, such as, where do mathematical gaps begin? Do the instructional techniques in early childhood impact secondary mathematics knowledge? How do instructional techniques lead to gaps in mathematical knowledge? Has the change to problem solving and student curiosity affected mathematical literacy in elementary students? So those were all questions that just kind of guided what ultimately brought us to our research question. And now I'm going to hand over the rest of the presentation to Andrew to talk about the literature review.
So what do the experts say? Well, the experts say that the traditional math classroom that we all know and love is teacher-led, focused on procedure, and it leads to a disparity between learning math and doing math. So in other words, the teacher introduces a new procedure, the teacher leads the class through solving a few problems of that same exact type, and then the students work individually to solve problems of that same exact type. Basically, math is something that's shown, practiced, and memorized. There's no higher level thinking, really. You just sort of change the numbers and then do the same exact problem over and over again. The ideal math classroom should foster student curiosity. It should be student-led. There should be problem-based learning, student-led solutions. Students should be encouraged to take risks, have fun, and collaborate. That brings us to the Common Core standard. So the Common Core standards, at least to some extent, address these problems. The authors, they recognized that there was a need there. They said standards should not just be a list of topics. It shouldn't just be about answer getting. It should be more about learning math at a deeper level. And the scholars agree, the research agrees that while they're not perfect, the Common Core standards do point us in the right direction, at least. Common Core standards focus on teaching number sense at a deeper level in elementary school in order to have a solid foundation for that upper level math. So even in learning basic arithmetic, students are taught a deeper foundational understanding of math rather than just, here's what it is, memorize the answers, the end.
Thanks, Andrew. And that brings us to the methods section of our research project. There are 3 principles that we'll be using to guide us through this data collection process. 3 principles that will help ground our behaviors as we go through this. And first and foremost is being true to the research question, and second is being true to the problem statement. Recognizing and remembering what it is and why it is we're doing what we're doing. Thirdly is being true to the ethical collection of data. We really need to stay focused on securing the data that we collect and respecting the privacy of the participants. It's no small feat getting permission to be inside teachers' classrooms and observing. And we recognize the anxiety that may cause and create in those teachers. We're not a part of their community. We're outsiders. And coming in to observe, we really need to be aware of that. And so we're being very mindful in that we need to conduct ourselves as professionally as possible. And we need to think like scientists. We're there to observe. We're looking through a window. That's very important. We want to catch authentic instruction. So that is our mantra. Those are the principles that we're going to use to guide us through this process. Let's take a look at the steps involved in the data collection methods. First is create and calibrate. What I mean by create is we're going to need to create the documents and the tools that we use to collect the information during our classroom observations. More specifically, we're really looking at a pretty specific component of the instructional cycle in those math classrooms. We're looking to see how teachers teach math deeply. Is it through problem solving? Is it through a method? Is it through rote memorization? And I feel like the forms that we use are going to be pretty vital because the wording of those forms needs to elicit the type of information that's pertinent to the theme of our research. We need to collect data that speaks to the research question. We need to collect data that speaks to the problem statement. That's only going to happen through the intentional design of our documents. Calibrate. So before we ever get into the field and observe teachers, we need to create a common language. For the purposes of this research project with our team, we need to have a common language. Are we specifically noting, using the same terminology, the components of the instructional cycle in a math classroom that we should? Are we using the same terminology? Are we labeling it the same? This is going to be important for our data validity and verifiability later on in the research. So I feel like that's very important. We're going to have to go through an entire observational cycle and calibrate our thoughts, our words, our terminology, so that we're all on the same page, speaking the same language before we get out into the field. Now let's talk about getting out into the field. There are 4 team members. Each one of us is going to conduct 8 one-hour observations in a math classroom as the primary observer and as a secondary observer. So we'll rotate through. Primary observer will be one who gets into the classroom observing a teacher, and that's the first time that teacher's been observed. We'll rotate. A secondary observation will take place with a different researcher. I really want to create a large enough sampling that our data is valid. Okay? We'll collect that data. We'll secure it on some dual encrypted servers. We'll make sure to remove any identifiable information. If we record, conduct video observations, we will not have any identifiable information of the students or teachers that are participating. Teacher participants will also be issued a participation code, and that will be used in lieu of any names or other information that could be used to identify them. All right, analyze and conclude. So next steps. Once we've recorded, once we've done all of these observations, we've submitted our information, we've put it in data form, we're going to get together and we're going to be meeting quite regularly, I imagine. I anticipate, just in terms of doing our observations and overcoming logistical issues, we'll be meeting once a week, either via Zoom or face-to-face, to make sure we're staying on schedule with our research and our observations. At the conclusion of all of the observations, we will be having analytical meetings, and we want to go through and we want to see what the data says. We need to synthesize that information, and we need to put our concluding statements. What does the data say? We need to let the data speak for itself. Once we've done that, we need to move on to reflect and our next steps. I feel like reflection is pretty important because I don't want to make a decision too hastily. I anticipate when we've conducted all of these research observations, there being a sense of accomplishment and celebratory feeling about, hey, we finished. But I don't want that to be the overriding principle behind our actions. I want to reflect. Was there something in the process, in the research project, that didn't go as planned? Is there something we could have improved upon? Is there something that affects the data? Before we publish this, we need to make sure that it is 100% accurate and true. And we need to reflect upon our practice to do so, I feel, because that's going to drive our next steps. If we find an issue, if we find something that invalidates our data, then the next steps may be having to go back and conduct more observations or altering something that needs to be fixed. So I want to be sure and reflect upon our practices before we conclude our methods section.